Welcome to the second semester of Accelerated Geometry. For those of you that have had Mrs. Kubasek and Mrs. Fliniak, you are very familiar with these videos. If you have not had us, these are the videos. We are your hosts for the semester and for your learning for the semester. We always like to start with our math humor if we have it, and today we are so lucky we have one. So I'm going to ask you, who invented fractions?
Why, Miss Fliniak? Henry VIII.
Ah!
Ba-dum-bum.
All right, so 7-1 using proportions. You guys, we're going to start out nice and easy. Something simple, just with talking about the definition. You guys, a ratio is just simply a comparison of two quantities. It can be written three different ways. We have it as a fraction. We have it as literally 9 to 11, so talking it out with the word 2 in the middle, or that 2 could be replaced with the equivalent here, so 9 to 11. Either way, you can express a ratio. It's fine with us. A lot of the times we're going to work with the fraction form because it helps us solve more, but either way it's fine. So if I were to, in this example, ask you to write excuse me, the ratio A to C in fractional form, we're just looking for something that compares it like this, you know, A to C, A over C. Okay, our ratios can also be used when we're talking about slopes of lines. Okay, the ratio for a slope of a line is the comparison of the rise to the run, the change in y over the change in x. So if I asked you to write a ratio expressing the slope of this line, you would simply have to find the slope, the rise over the run. So if you remember, you have to take your y2 and subtract your y1 over your x2 minus x1. So if I label these, let's see, x1, y1, x2, y2, and if I go to work here, you have negative 2 minus 3 all over 2 minus a negative 1. Now, two negatives, you guys, this makes a positive. You end up with negative 5 over 3. So the comparison of the two, the rise to the run, the change in y over the change in x, gives you a negative 5 over 3. A ratio can also involve more than two numbers. For example, if you take a look at this rectangle, it says the ratio of the side lengths, so we have our width being 3 and our length being 7, the ratio can be written as 3 to 7, 3 to 7. It doesn't necessarily mean that the side lengths are 3 and 7, so it doesn't necessarily mean that these have to be 3 and 7. In this case, it does. However, sometimes the ratios are written in their lowest form, so this could be reduced. It could be the lowest form of what the actual lengths are. For instance, take this example. It says the ratio of the side lengths of a triangle is 4 to 7 to 5, and its perimeter is 96. They want you to find the length of the shortest side. Well, we're talking about a triangle here. I'm just going to draw one so that I have a visual. Okay, now it says the ratio of the lengths of the sides is 4 to 7 to 5. So let's take a look here. If I were to say that this is, 4, this is 7, and this is 5, when we're talking about perimeter, if I add up 4 plus 7 plus 5, there's no way I'm getting 96. All right, so this is our reduced ratio. Now, let me go through an example here on the side. Let's say I have a ratio of sides that's 4 to 12, right? Okay, now we would reduce this. It would be 1 over what? 3, correct? This is what you are seeing. You are seeing the reduced ratio right here. Our problem is we have to go back and figure out what the originals are so that I can find my shortest side. Well, in order to go back, if I use this as an example over here, you would have to multiply this first ratio by 4 on the top and on the bottom here, right? Now we're going to use the same idea. We're going to use it in this problem though. I have to multiply these values by the same number to go back to my originals. Now I don't know what that number is. When you don't know what that number is in math, we use a variable. So we're going to multiply these by the same number. I'm going to call them x. This should help us get back to my original. Now remember, we're talking about perimeter here, right? So if I add up all of these sides, 4x, 7x, and 5x, it should give me my perimeter of 96. Well, take a look, you guys. If I solve for x and plug it in here, I can find my shortest side. So let's add it up. You get 16x is 96, so x is 6. But remember, you guys, we're not done. We need the shortest side. So I'm going to take this 6 and plug it in. 4 times 6 gives me 24. So The shortest side is 24 centimeters. Now, if I want to compare or say that two ratios are equal, that's when this word proportion comes into play. It's an equation, which means we're going to add an equal sign now, that states two ratios are equal. Okay? The equality of cross products, we can tell whether or not these are equal by using cross products. Cross products means to cross multiply. So I don't like the way this looks. So I'm going to write A over B equals C over D. These two ratios are going to be exactly the same if I use my cross products and they're equal. So if I take A times D, which in this case are called the extremes, and they're equal to B times C, which in this case are called the means, then this is a true proportion. These are proportional to each other. Now you're going to have to remember these two vocabulary words, means and extremes. You're going to have to know which ones are the means, which ones are the extremes. I usually remember because A and D are going downhill. They're downhill skiing or they're snowboarding, which is extreme. So if I were to ask you, is this a correct proportion, show why or why not, all you have to do is use the cross products to see so. So if I multiply 3 times 20, that gives me 60. And then if I multiply 4 times 15, that also gives me 60. So I took my 3 times 20, I took my 4 times 15, I found my values, and in this case they're equal. So yes, this is a correct proportion. Please, I would like for you to pause this. I would like for you to do B, and then we'll come back and we'll talk about it. What you should have noticed is when you use your cross multiplication, you have 7 times 72, which gives you the 504, and 9 times 63, which gives you 567. These are not equal. So is this a correct proportion? No, 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 no. Now, a lot of times we're looking for answers that will get us a correct proportion. So they'll have one piece that's missing, okay? In this case, we have x on top, and we're looking to see what can x be to make this a proportion. What can the x be to make this equal to each other? Well, this is just going to need some algebra. So we're going to use our cross multiplication. We have x times 35, which gives me 35x. We have 11 times 5, which gives me, 55. So in order to make this a correct proportion, x will have to be 1.57. All right, let's do the next one. I would like for you to cross multiply, set these up, please, and then we'll come back. So pause me, we'll come back and we'll talk about this. All right, so if you set this up, this is what it should look like. You have your 8 times your x minus 2 equals the 3 times x. You're going to notice you're going to have to multiply everything over here by this 8. So you're going to have to distribute. You have to be very careful because if you just take 8 times x, it's not going to give you the same answer. So you should have 8x minus 16 equals 3x. If you solve, you get 5x is 16. So in order to make this a correct proportion, x will have to be 3.2. All right, so for this last one, I would like for you to please set this up. And if you can, go ahead and distribute it through, and then we'll meet up afterwards, and we'll talk about how you got this. Okay, so if you distribute, you get x squared plus 6x equals 27. All right, so now you're going to have to think back to algebra. We have an x squared, and we have an x here. The only way we're going to solve this is if we bring this 27 on over, and then we actually have to factor it. So if I bring the 27 over, I end up with x squared plus 6x minus 27 equals 0. Now, if you remember, I'm looking for multiples of negative 27 that add to equal a positive 6. That is a 9 and a negative 3. So this should be x plus 9 and x minus 3 equals 0. So you have two solutions. To make this 0, we have a negative 9. To make this 0, we have a positive 3. All right, it says the perimeter of this triangle is 72 inches. The ratio of the measures are 3, 4, and 5. Now, we did an example like this in the beginning. I would like for you to try this one. Come back, and then we will see how we do. All right, well, with any case, a picture helps, right? So remember, 3, 4, and 5 is the ratio. In order to get back to my original, we have to multiply it by the same number. In this case, I used x, the classic. Now it's perimeter, so when I added 3x plus 4x plus 5x, it gives me 72. So 12x is 72. You should have gotten x is 6. But once we're done, we're looking for the measures of all the sides. Sorry about the phone, you guys. So I plug 6 in to each one. 3 times 6 gives me 18 inches. 4 times 6 gives me 24 inches. And 5 times 6 gives me 30 inches. All right, this is very similar. We're still talking about a triangle. But now we're actually talking about, we're talking about the angles. So again, I have 2, 3, and 5 as my ratio. You guys should remember that adding up all the angles in a triangle is not going to give me 10 like this says. It's going to give me 180, right? To get back to my original, again, we have to multiply each one of these by the same value. And when I add these together, 2x plus 3x plus 5x, we should get 180. Go ahead and solve for x and then find the measure of each angle. All right, so when you added this up, you should get 10x is 180, so your x is 18. Then when you plug it back into each one, you should have had 36 degrees, 54 degrees, and 90 degrees. It says, given that 18c equals 24d, I want you to find the ratio of d to c in simplest form. Well, remember, you guys, to get to this point right here, we have to use cross products. Okay, so 18 would have to be multiplied to c in order to get that 18c. And 24 would have to be multiplied to d in order to get the 24d. All right? So if I want the ratio of d to c in simplest form, the ratio of d to c is 18 to 24. But in its simplest form, when we reduce, we should get 3/4. Marta is making a scale drawing of her room. The room is 12.5 feet wide by 15 feet long. Let's draw a picture of that. So 12.5 feet wide by 15 feet long. It says on the scale drawing, the width of her new room, so here's the new room, is 5 inches. What is the length? Well, in order to do this, we could set up a proportion. Okay, we know that the the ratio of width to length over here is 5 to x. It should be the same here if we want it to be an equal proportion. So 5 is to x as 12.5 is to 15. That 0.5 is the 1/2 here. Okay, now you could have also compared width to width. So you could have also said 12.5 compares to 5, and then 15 would compare to x. Either way, I want you to notice you're multiplying the same values. So when we use our cross products here now, you get 12.5x is 75, which leaves you with a length of 6 inches. So what I would like for you to do now is, if you have any questions, first go over the notes, and then secondly, make sure you bring those to class, because I really want to make sure that we understand what's going on. This is the beginning of the semester. We start fresh and clean. We're going to ask a lot of questions, and I'm going to help you along the way.